Hello everyone, we will be continuing with the metallurgy chapter and I hope you all are well prepared with coordination chemistry chapter for the test. If not, you can visit the videos once again and get ready with that chapter for the test. Now today we will be discussing some common purification techniques for metals. After extraction of the metal, purification is another important process, another important step, and there are multiple processes multiple processes which we apply, which we use for the purification. Now starting for a first method is distillation. Generally a metal which can be distilled easily, vapor can be formed easily. For them we use the process of distillation. The method is very simple. We vaporize, other impurities remain as a solid phase, and the metals which can get vaporized and collected and can be purified in this method. Generally zinc, mercury, gallium, these metals can be purified in this method. Zinc is very popular here, zinc and mercury. Second is liquation. Metals which are having a low melting point, they can be purified in this method. We can go for liquation, fractional liquation, and metals with low melting point, they forms the liquid, and other impurities they remain as it is. Lead can be purified easily this method. Third, which is a very common, very important, and you all have read, is electrorefining. Electrorefining is a process to get the very much pure metal, and in this case we use electrolysis process. It was there in your class 10 that in anode we use the impure metal, cathode we use the pure plate of the metal, then we take electrolyte which must contain the ion of that metal which we want to purify, and then we pass the electricity through it and we get the pure metal, and in anode the impurities settle down as anode mud. I guess you can remember we did the experiment, we read about copper purification using aqueous copper sulfate acidified, and then anode mud forms at the bottom of the anode, and at cathode we get the pure copper, as from an anode Cu2 plus ion gets generates, which forms the deposit on the cathode. This is an excellent method. Fourth is zone refining. This is a method to get extra pure metal, and generally germanium, silicon, this kind of metals are purified through this method.
Zone refining is a special method to purify metals at a very high degree temperature, and this also gives us a metal with very high purity. Germanium, which is used in semiconductors, is purified using this technique. A circular heater is placed around germanium rod at one end, and it is placed in an inert atmosphere. The heated zone of germanium melts along with the impurities. When the heater shifts to the next zone, the pure germanium crystallizes out, and the impurities get melted and gradually moves to the next zone. When the heater is shifted from one end to another end, the impurity is also driven to the extreme end from where it is discarded, and finally we get extra pure germanium through this process.
Next is vapor phase refining and zone refining. In case of zone refining, we get high purity metal. In case of vapor phase refining, generally this process is used where a metal in its vapor state can react with the reagent, and the compound form which can be reduced back to metal very easily. As for example, if you want to purify the nickel, in the vapor phase the nickel reacts with the carbon monoxide to form nickel tetracarbonyl, which can be further decomposed to pure nickel easily. So you need to have this idea that they will form a compound at vapor phase, and from there we can get back to the pure metal very easily. Other impurities will not react with that particular reagent, of course, so they will remain unaffected and they will get separated. Next is poling. In green wood poles are used which contains hydrocarbon. The hydrocarbon presence in this green poles reacts with the compound Generally cuprous oxide Cu2O is used here, and which is getting reduced with the hydrocarbon presence in this greenwich, and then they starred with spores, they are starred in that solution, and we get the pure copper from that. And finally chromatography. Chromatography is a technique in which components which are very similar types, and also if the component present in the chromatography present in the mixture is a very small in amount, it can be purified through chromatography. You read about paper chromatography, but the most popular one to separate the components of mixtures is column chromatography, where generally we use glass columns where it is packed with silica gel, maximum cases silica gel alumina, and then we pass a solvent through it, and those components, their solubility vary with each other with respect to that particular solvent. Now one which has more solubility will come out easily, and by vaporizing the solvent we can get back the components, and depending on the solubility, concept is very much similar like paper chromatography, but paper chromatography, the thought that they have different solubility, they will rise. So similarly here also we are packing it, giving a bigger shape, and then the solvents is helping to coming it down and then collecting in a different flask. So that's column chromatography. So these are about the purification techniques. So these points I hope you all are revising, and next day we'll discuss some other points, and we'll be continuing with P block as well, but keep revising coordination compound. Take care and bye.